Hey everybody, welcome to the Propeller Live Forum. It's April 10th, 1 p.m. Pacific. Today we have Lachlan sharing this project with the RP 2040, and rather than tell you about it, we'll let him do that. And Stephen will also give us an update on Visual Studio Code. And is there anything else anybody wants to throw on the agenda, like questions, something to share, or similar?
I have some pointer stuff we could go over because I think anyway, it would maybe be helpful to get people's opinion on some things.
Pointer.
Okay, Skippy. Who else? All right. Well, as you know, you could just jump in anytime, unmute yourself, and talk about whatever you want to talk about or ask questions. It's a good time to get technical help if you need it too. So anybody move that we adopt the agenda and get going?
Mm-hmm.
Okay. Good morning, Lachlan.
Good morning. It's certainly morning over here. It's about 6 o'clock. So
Oh boy.
yeah. I'm just going to jump right in and share this screen. Let's remember how to do that. Okay.
Have you had your first cup of coffee?
I have not, and it's a problem.
I'll call the delivery service.
Yeah. We have a coffee grinding factory 2 doors that direction.
I saw that in the picture, just to the right of your shop.
Yep, that's it. So I think we can do it like this.
Hey, Lachlan, before you start, can you summarize what detection systems does? Because it's interesting and it'll fill in the
Sure.
stuff.
We manufacture food inspection equipment. We make we make machines which work where maybe vision systems aren't quite suitable. Yeah, industrial production lines, food factories, pharmaceutical manufacturers sometimes. Yeah. So one of the things we strike as a sort of a constant issue is when you're on a production line, you want to record what's going on. And we're also trying to, build a system which is going to respond to what's going on that production line. And one of the easiest ways to do that is to get whatever you're trying to look at into a visual format. So sometimes that will be as simple as, putting a LED on the production line to show when you think you've detected a reject, and to then film that LED with a video camera so that you can then synchronize what's actually happening, and the relative timings and to get everything synced up. It's one of the reasons we like the Propeller 2 chip, is because it's so good at real-time synchronization. You can have different tasks operating independently without affecting each other. So this is why we're attracted to the Propeller 2. What we're doing here is actually part of a useful tool, which we've recognized we should invest the time in making. So Brian, who's Ozprop dev on the forums, has spent, I guess, a good part of the last 3 or 4 months developing this for us. And what it is it's a tool that converts the a propeller output, like video output, into UVC video, so that it can go straight into a supervisory PC, and that PC can then run just standard video recording software, or it can easily take screen grabs. What it means is that the process of acquiring the visual information and the synchronized data can become almost automatic and a transparent process, which results in better productivity and keeps you focused on the actual engineering problem that you're trying to solve. So we've been using for this task the RP 2040. I became aware that it had some demonstration code in this area. It's not the first processor we've looked at. We've also looked at Cypress FX2 or FX3, and we've looked at the there's a couple of other there's some macro silicon products, and there are some
You should be able to do low-res UVC just from the P2 itself.
yeah, ultimately I expect we will be able to. But there's some good reasons why we've taken this approach, and I'll go into those, towards the end of this presentation.
Also, I made that font.
You
Just
made
let it be known.
sorry?
I made that font here.
Have you declared it impossible?
No, I made that font in the picture, is what I want to say.
Oh, right. Yeah, good. Yes.
Just because, I don't know, I recognize it.
Yeah. So what you see in this picture here is just a Windows camera application. So it's showing what Brian set up is a P2 video. You'll recognize the font in there, and that's going out through the UVC and straight into the PC as an image. And so you can, from here, you can just hit, record to record it as a video, or just hit the camera button to record a snapshot. And, then once you're inside the PC, obviously it becomes easy to send it on or share it or put it on a Zoom conference or any of those kind of things.
So you're using probably HDMI to do this?
No, this is the thing. It bypasses HDMI, so you don't need a capture device. This is just literally a USB link and the RP2040.
Oh, okay, which is probably USB 2.0 or something like.
Yeah, I think it may be USB 1.1 underneath it. It's not a particularly fast system, and this is one reason why we'll probably come back and revisit some of the more expensive and external systems, but they've all got their issues as well. So for us, this is around about what we need. We don't need a massive resolution. It's amazing what you can get done with with not so much resolution. And with things like AI and machine vision, they don't really use high resolution. A lot of it's working on quite a cropped number of pixels. So yeah. So just a little bit of background about UVC. It stands for USB Video Class. It's what your typical webcam uses, and it has drivers built into all the operating systems, so there's nothing to install. Everyone will be familiar with just plugging in a webcam and having it, work with the various software which needs a camera input. For us, the main use for it is being able to do the graphic development without having a monitor. So a lot of the time we've lugged a monitor into food factories. We will just be able to do it on the laptop and record and, keep it nice and clean. Good for instrumentation, I think. So presenting some kind of measurement in a format which can easily be recorded or used with OBS software, so you can sort of blend it with other camera or inputs, including HDMI capture devices, etc. And putting text overlay. I remember Phil Pilgrim did a really neat job with the backpack where he could add text to an existing video signal. And I suppose in a way this brings it forward into what the P2 can do. So this is our setup is really very simple. And here, we've got in this case here, it's actually a Raspberry Pi Pico board, like a standard $4 Pico board instead of our hardware. But you can see here that there's really just there's a prop plug connection between there, and there's actually just that single data signal which is coming from the P2 and sending the video across to the Pico, which then renders it through to the P2. These couple of wires aren't actually connected to anything meaningful. We're using a 6 megabit per second serial data link. That seemed to be what the Pico was happy with. Obviously, the P2 can send faster if we decide to go faster, or if we get some code which will work properly at a higher rate. But yeah. This secret keyboard, that's a mistake. That should be a secret keyword. We just send like a single 32-bit keyword, which is effectively a reset to start a frame signal, and that just sets the video buffer counter to the top left Then after that, every 2 bytes that come in are a pixel of video. We've seen rates up to around 15 frames per second. It seems to top out, around 16, 17 frames a second. And so we are happy enough with that. That's good enough for what we do. The resolution we're running at when we're testing that is somewhere around 200 by 30 or thereabouts. And on this one here, this is 192 by 128, this image here. So 24 by 16 characters, what Brian set up. All right, so I might pause there. Are there any questions so far on what we've got going? Okay. So we've also developed our own development board for this. This was a experiment which worked out well. So the idea with this was actually just to take a Raspberry Pi Pico design. So this is just the Raspberry Pi Pico minimal design, I guess you call it. And we wanted to make it easy to work with the P2 accessories, which we already have. So, especially things like this control board and other things which we can plug in. We've got a whole heap of prototype boards as well. So this, we added a few things we missed. So Brian's always a big fan of debug LEDs. LEDs for debugging, and so there's 4 separate IO LEDs which are just signal when Raspberry Pi IO 0 through to 3 are turned on. Over on the right hand side here we have a Propeller a prop plug header plus 1 IO pin which we use, and this can be used for sending the video signal in this direction from the P2. So the Raspberry Pi IO starts at 0 here and winds its way around and ends up at 28, 29 up here. And we have some RX and TX LEDs near the prop plug. And we also can fit, there's a kind of an oval, there's some extra pads up here which enable us to put like a 16-bit rotary encoder. So you can select different programs or different functions, or you can load these up with analog potentiometers, like a little 10-turn pot, which can mount in here. Couple of quick connectors so that we can connect onto SparkFun 1-inch square modules, which can mount in here and keep it kind of tidy. Costs us around about $5 to get this board made in a batch of 50. So we've just gone for it, and we've used probably, I don't know, 10 or 15 of these in development, where we just burn different firmware onto them, and once something works, you just leave it, move on to the next thing. Yeah. So any questions about the board?
One question. So where's the camera connecting to? Or no, wait, excuse me. You're generating a video signal.
Yeah, it's
Okay,
generating
got it.
video. But you're right, Chip, in that if you wanted to send something in, if you had a P2 over this side, it's going to be sending the video signal in through this extra IO pin, but it can be from a camera, and then the P2 can overlay video on top of it, and then send the combined video in at 6 megabits per second in this pin here, and this will synthesize it into the UVC video. So you can use it with the camera. It's just we'd have the P2 aggregate whatever we need, including quite likely you'd have multiple camera sources. You might use some of that code that Saucy Soliton had with the did a pretty good job of color video capture.
Okay, I was getting confused. I mean, your objective really is to generate a graphical screen based on some sensor input, and then output that, and then have. Okay.
And to put overlay on it, so you might have some live data that you're sensing, and you might want to put that inside the frame, and so everything is kind of synced. This is what I'm seeing, if you look at when like they're doing AR training, they're often putting extra information onto onto that stream. You know, it has a box around it and it has a value, what you know, what it thinks it's found or whatever. So all that kind of information can be encoded or included inside the video stream. And so this just makes it easy to aggregate and bring all that stuff together, using the flexibility of the P2 to achieve that.
Lachlan, is this picture you're showing here of the board, is that the same board as shown in the previous image with the P2?
It's technically it's not. This is actually the basic Raspberry Pi Pico board. You know, it's you can use either. So, you know, we don't. This is a development board we use for its additional flexibility. But at the end of the day, you only need that one I/O pin, and so almost any board which has got a Pico processor on it would achieve what you need. The only thing is we've you know already compiled some firmware, which means it puts it out on a particular pin, and as long as your board has that pin available, that'll work with the images we've already made, or you can compile again from source. You know.
Hey, John McPhalen was asking what language you used to write the Pico code in.
So Brian's had a bit of fun because he describes himself as allergic to C, and he's written some C code to tie all this together. I should explain that this is built on top of the tiny USB code and stack, and so that's written in C, and it's required Brian to get up to speed with the C programming and just you know, compilation. So it's Brian's naturally loves low-level stuff. So before doing the C code, he was sort of getting up to speed with the Pico in an assembler language, like a kind of a bare metal kind of way. And then you know, sort of moved on to the C code to get all this running. So yeah, it's C underneath for this, but obviously we prefer to be coding in high level languages for development once we get, you know, really running. So it's just really the underlying binary blob, I guess, which we've compiled in C from C.
Hey, if this UVC protocol works in 1.1 USB, and we could code that on the P2, would the Raspberry Pi then have any, in this type of application, would it be doing anything still, or could we like just pack it into the P2?
Yeah, look, potentially yes, this is possible. You know, if someone had some time, one thing to do would be to try and compile the tiny USB code into the P2, probably looking at using Eric's
Oh, C.
Yeah, C++, the RISC-V emulation C compiler, you know, might have a chance of putting this together. So
unlikely, because the actual USB isn't a standard USB controller. Normally you'd use like a standard USB controller block. The P2 doesn't have it, so you have to write different USB code.
Yeah, so there may be a need to write there's a hardware abstraction layer within tiny USB, and just to write that thing, but I'm not sure it's not just bit banging underneath it all anyway. So you know, it's something to look at whether it's possible. But Chip, back to your point, the other thing is that the USB, I guess, on the Pico is a more official version than the Propeller 2. So, you know, it has a device, presumably they've paid some USB royalties or something on that. And so I think we'll get to the point where we can do the same kind of thing on the P2. But it's an unknown quantity as to, you know, when we'll get there, I guess, is the thing.
Right.
So, yeah. There's another dimension which I'm about to get into too. So following on from the test as a UVC video device, this is a separate trial where we're trying to emulate a prop plug using the RP just to see how it goes. So like the UVC, the Pico here is using a CDC UART serial port, and the advantage of that is that the drivers are built into the operating systems in the same way. You know, you don't have to install special FTDI drivers. The thing that's missing from the standard code is the DTR signal, and Brian did some work exposing that signal so it can also be used to reset the P2 and behave like a standard prop plug. There is, you know, a dual serial port possible. I don't think we've actually had that running just yet, but in the tiny USB code there is a demo which includes 2 serial ports within the one USB cable. You know, so you have 2 ports, one for debug and one for your application, running concurrently. And again, you don't need a driver. You just enumerate it, and you get a couple of ports on your PC end that can be hooked into those functions. The speed we've been able to attain 3 megabits per second to the P2, but only 0.7 megabits per second. Should be megabits per second, not megabytes per second. Sorry. To the PC. So there's a kind of a bottleneck with the PC going back, with the Pico going back to the PC, which is to do with, I think, the packet sizes and things. Like it's maybe just sending single byte packets or something. It's not really doing a particularly efficient job. But you know, that's just where it is initially. And we have tested this okay with most of the software. It works fine with FlexProp, Peanut, Python loader that Brian's written, VB tools, all those work fine. We have a minor issue with the prop tool, which we might have to talk to Jeff about when it gets to a particular program size. So it works fine for smaller code, but once you hit larger code at about 180 kilobytes, it seems to time out. There's some kind of thing going on, which I'm sure we can get to the bottom of. And then on our future work, so the interesting thing that's about to happen, so MicroPython 1.23 is the next release of MicroPython that they're currently working on. It's going to incorporate a USB stack which is mostly written in Python by a friend, Angus here, who's been working on it for the last 18 months or so, I think, in total. So the advantage of that is that it'll be possible to kind of shape and modify the USB code at a sort of high level way, and create sort of hybrid devices. So we might want to put endpoints for both UVC and the serial link, or more than one serial link, into it's like a composite device, and have that working. It might be also possible to expose the MicroPython frame buffer so that it just appears as a UVC, webcam port, signal. We've struck a couple of Linux and Mac issues. That's really not, under MicroPython. That's just when we're testing our stuff, we've got a couple of things we need to do further testing and possibly changes on. And the MicroPython would be a good way to sort of get to the bottom of it, because you've got low-level access to the endpoints and the descriptors and how it's all set up. Mass storage class. So there's a potential here to make a device which uses the Raspberry Pi Pico for its drag and drop feature, where you can just drop a image onto that device. It's what they call a UF2 file. It's got the extension .uf2, and that could incorporate both the code for the Pico, but also have a P2 payload underneath it all. Now, what we propose to do is have it so that gets dropped and stored on the Pico's flash, and then the P2 sort of just holds the Pico in reset while it retrieves the file from the Pico's flash, and loads. It could be quite a seamless and quite a fast operation. We've done similar kind of things in commercial products before, and we got them up and running, so we don't really see a technical issue with it. Yeah, we also some of the tools, like some of the Python programming tools like Phony and perhaps Mu as well, have the ability to send the UF file sort of from within the IDE directly into the controller. So they have like a save as, but instead of saving it on the PC, it can save it onto the mass storage device direct into the thing. It's equivalent to flashing the microcontroller, but it's in a way which is a bit more intuitive, I guess, or for people who are used to dragging and dropping files, but aren't yet used to programming Flash with tools. So yeah. We'd like to get the reverse channel with the webcam working. So normally with webcams, you can also send data to the webcam saying what, say, focus or exposure or, you know, color balance you might need to change. We'd like to get that up and running so we've got a command channel running the other direction. We'd like to get audio running eventually. You know, I haven't worried about that yet. And then we'd also like to shrink our circuit board down so that we, you'll notice that this core here is all kept deliberately very narrow. And so if you take off the, you know, the pins at the top and the bottom, and you move the regulator and the flash onto the bottom of the board and drop the user button, then the whole thing shrinks down to something closer to a prop plug kind of size. Yeah, and finally, yeah, a couple of links. Sorry, I'll put this up in the forum, but yeah, I'll put some links to what MicroPython are up to, and also the tiny USB code which is underneath what we've been doing, and also the compiled binary, so people can just drag and drop this onto their own Pico board and have a play. Right, that's about it.
Ooh. So a lot of the draw here for the Pico is that it's got Python and it has some kind of manipulable USB interface.
Yeah, I would say it's just got a combination which makes it useful right at this point in time. So the MicroPython drivers for the USB, which Angus is working on, are coming out for the Raspberry Pi 2040 first, and also the SAMD thing. So the next release of MicroPython will have these options for really, you know, customizing your own USB links. And it should be nice and easy to, you know, to build things with that. Yeah, there's no tiny USB will run on a wide variety of microcontrollers. I've talked to Roger. I've pestered him a few times about, you know, whether we could get this going on the P2. It's primarily the C compiler which holds us back in that front, so from doing it directly. But as I said, there's some options from Eric which might be able to do it, or it might be possible to hack the code. You know, with somebody with better C skills than we have in-house would possibly be able to change the code so that it, you know, removed C++ kind of references or whatever, and could possibly be compiled with Catalina or something like that. From our point of view, this is just a tool that we need, and so we just need to find the easiest path. As I said, we've looked at a couple of other options from the FTDI, FT602, and the Cypress things, and they all involve significant kind of effort to get going. This we were able to get going fairly quickly. Chip, you know, I fully expect that in time we'll be able to do this natively with the P2. But this is just something we need to get going so we can build.
No, of course that's A-okay. I'm just kind of trying to get a handle on it, because I'd like the P2 to be this attractive for this kind of use at some point too.
Yeah, I think in a way, you know, the thing to do is really demonstrate the use case for this. You know, the things I'm talking about where you sort of add the live data on top of the video stream or a synthesized video stream. These kind of things the P2 excels at. And so, you know, I think this will kind of enhance or demonstrate the, you know, what can be done. And it's sort of important probably just to get there and not worry so much about how we've got there right now, because, you know, the P2 has certainly got the ability to to do high-speed interfacing and to do all of this, but it's a variable kind of development effort. If I said to Brian to now turn this into P2 code, he would absolutely do it, but it's a variable. You don't know how long it's going to take, and so
we need a little more kind of like infrastructure to support all that stuff.
Yeah. What Roger says is, we just need the P2. We need the compiler to be able to compile tiny USB directly. If we had that, we could also pretty easily natively compiled MicroPython as well. So it's a compiler challenge, I think, primarily, which would enable this. And so if there's one area which we'd sort of like support on to make this kind of thing easier, I think it's really on the compiler side. So yeah.
Got it. Okay. And it must have 2.0, right? I mean, because of when it was built.
Yep. Well, yes, I believe the tiny USB, there's a matrix which shows on which processor it runs at 1.1 versus 2, and I think the RP2040 it just shows us using USB 1.1. I don't know if that's still current or up to date. It's kind of consistent. If we're finding that the limitation is kind of sending video in at 6 megabits per second and USB 1.1 is 12 megabits per second, it probably sort of makes some kind of sense that this is where the bottleneck is at the moment. But yeah, I think we could we could probably find a way, use a different processor maybe, and we will get up and running with a higher speed link. But keep in mind the resolution can be set arbitrarily, so you can have 1920 by 1080. It's just going to be at a pretty
I know, yeah,
frame rate. So
I think those like dedicated UVC chips, they'll take really high resolutions with like any sort of timing that you want.
Yep. So some of the macro silicon or they're just natively built to do this. So
yeah, but if you just have 1.1 USB, you can just hack that up directly. Interestingly, if you want just text, what you could do is you could pretend to be motion JPEG format and then have a bunch of pre-encoded 8x8 tiles with the text characters in them, and then just append those into the bit stream.
Yeah, that would work. You're right. You could do that. Yeah.
So like for the P2, like a while back, I got CDC class device working on the P2.
Yes, that's right.
Have you seen that?
Yeah, James.
What is
CDC? Is that correct?
Sorry, what was that?
Oh, what is CDC? Is it some kind of a?
That's the serial port one. That's when there's
okay. Okay. All right. Kind of like the FTDI stuff.
Yes, like that, but like real.
Yeah. Just coming back to James. James, it was your code, was it, that because I did test that CDC code and it works remarkably well. You get a really high serial data rate. And so what James is pointing out is there's already some code in the forums that will do the CDC function. And in that thread, you'll probably see me peppering and saying, what about UVC? But yeah, that code was certainly quite impressive because it was natively doing the CDC at a decent at a decent clip. We were quite amazed at how fast that serial link was.
For UVC, you probably just need to change the descriptors. I think it's
the
same idea.
It could well be that simple. That might be the easy way to sort of cut across to just using the P2 directly. Obviously, there's not a huge cost penalty in adding an RP2040, but yeah, it'd be really great if we can get this all inside the P2 and just have a single code base.
Yeah, so I mean, like the UVC is something that I've wanted to do, but it's just USB is just kind of a pain or so. But yeah, I do think that like Ada said, just just need the right descriptors for it or so, and then, instead of, sending data to the serial port or so, you'd be sending it to the, the video program.
Yeah, yeah.
Yeah, I think yes, I think there's a lot of hope there with that code and how well that worked. I would love so what the plan is basically, once MicroPython comes out, we will look at getting that right. With the descriptors, it has, kind of low-level access to all that kind of stuff, but in Python. And so if we can get that up and running and find out what descriptors are required and, get that working, then we can probably know what we need to do on the P2 side and bring that inside of the P2. So it'll be really great if we can get that running, and then it's just mean and lean and all inside the P2. So yeah, it'd be good.
Yeah, I mean, what I had this thought, back when I was working on that or so, is like the, like the P2, like the smart pin USB mode, is like such, very low level compared to other USB hardware and microcontrollers.
Yeah.
And in fact, like it seems like, I don't know if this was a bug or something, but like the USB host code I saw, is continuously polling the data from the USB.
Yeah, it needs, you mean the code that was written for the P2?
Yeah.
Yeah, no, a cog has to be on task watching that, because, I mean, you're in control as the host, but you have to be there when communication turns around, and you have to like really focus. So it does hog up a cog, to handle a USB port. But for lower rate things like HID devices, you could use one cog to handle a couple of those links, because you're never saturating the data time.
Yeah, remember that from like a couple months ago where I had like 7 at once?
Oh, you did? Yeah.
Yeah, remember. It was very funny. I made like a joke.
Yeah, the HID
like I always
stuff,
do.
the data payloads are small, so the conversations are very short. So you could multiplex one cog and handle a bunch of those kind of ports.
Like when I thought like the smart pin or so, I thought that, it could generate an interrupt when there is new data from the USB, but it seems like I was getting like too many interrupts.
Oh yeah. I designed it. I should have made it work a little bit different. I mean, I think it has an interrupt on change, but the trouble is, anytime anything transitions, that's a change. So yeah, you'd get way too many interrupts. So it's kind of like, I just made it so I dedicated a cog. But I mean, you could possibly make it so it runs on interrupts, but when it's busy, it just hogs a lot of the time, because it has to do things. It has to kind of do retries in some occasions, and it's I don't know, it just seemed to suck up a lot of the cog's attention. But that could be rethought, but I haven't really rethought. I got to the point in my work where, okay, I know I can do this now. And then I just kind of got sidetracked onto some other things, but I'm going to circle back and incorporate that USB stuff and do, proper HID support. But now it's just kind of proof of concept. I know it works. I know it works right. I just got to come back later and finish it.
Okay, any more questions for Lachlan?
Oh, so like the UVC class, how is the data formatted? Like, is YUV, JPEG?
Yeah, they're like 64-byte endpoints, that kind of thing.
Yeah, each pixel is a 16-bit word. It's like a 422 YUV coding, I believe.
Okay.
You can use all sorts of formats, actually.
Yeah.
You can use JPEGs, which is actually what the camera that I have here in my very hand does. It's actually USB 1.1, and that's why it sends JPEG frames to the PC, which is very strange. But it's possible. And you can also do, of course, uncompressed RGB. You can probably do 16-bit RGB, but I'm not sure of that. would have to check the specification if it allows it. And then you'd have to check if it actually works.
Right, I'm going to have to depart in about 3 minutes. So if there's any questions, let us know, or I'll put something up in the forum so that we can continue the discussion there. But yeah.
Thanks a lot for showing us all that, Lachlan.
Thank you, Lachlan.
Yeah, no problem.
Yeah, don't depart. Just go away for a while, then come back, okay?
Sure. Have breakfast, come back.
And thank you. That was fun to
Stay
see.
for lunch. Yep.
Great. Okay, so we can move on to talk about pointers with Chip, or Stephen, do you want to update us on Visual Studio Code?
Yeah, have Stephen talk.
Okay, Stephen talk. Put him on the spot.
He's doing a mime routine. Watch out.
Hey, Stephen, you're muted.
You're right. I'm sitting here talking and muted. That's terrible.
We thought you were setting up your display only, so we missed everything you may have said.
Oh, thank you. Okay, so I've recently done some updates to the extension, and a lot of it has to do with the object dependencies and how this tree viewer was coded. And so I rebuilt it to have underlying data structures that just understands all the dependencies. Reason I did that is because then I can refer to that data structure both in the tree view and for the new capability we see, which is this. So we now have the ability to take any object you're working on and immediately generate the tree report that you see when you got the hierarchy out of when you're doing an archive on Propeller tool. And so I formatted it nearly the same with identifiers that tell you it's not coming from the Propeller tool. Let's see here. Having that done, then we also went and I'm playing a little bit with these symbols, and now everything purple are eligible to be in the public interface of the object, and so the colors of the icons are a little bit more helpful. I'm still trying to figure out what's going to show up in this outline, but for right now it's better. So that was one change, the new report and the improved hierarchy. The hierarchy also has now a functioning expand and collapse, and what it does is it'll collapse to just the top file and its dependencies, and then it'll expand to the full tree. So I built that so it's automatic. So you can do that. So those are the major changes. There were a number of coloring and highlighting fixes where I wasn't handling expressions as an index to a list of object instances. That was fun. And so those kind of things are now being highlighted correctly, and we made improvements there. The next thing I'll do is, I don't know if you've been following, but we've been working on preliminary. These are just very preliminary support for FlexSpin. And so you notice we have conditionals, and when you're first running FlexSpin, it does not recognize any of the preprocessor directives. And so I'm beginning to kind of experiment with how should they be recognized, and what am I looking for? FlexSpin directives. So we have an option here that's been around for a while now, but I'm going to turn that on, and that should change our behaviors. Let's see if I got the interaction right. Yeah, no. It should automatically reload that file with the new behaviors. And now what you see is that as soon as I enabled it, it's handling these conditional compiles now, recognizing them, and it's graying out the areas that...
Or oranging them out.
I know, hold on. I want to talk to you about this because I want you to show what you're seeing too, because that's too much fun. But anyway, so we have the highlighting here, and the way this is working is we also had to go all the way up to here and handle these, because a lot of those variables, their definitions are coming in from external includes, which is traditional when you're compiling with a preprocessor. You're going to do a number of things with includes, with symbol definitions. It's typical to be loading them from other files in includes, and it's also typical to be providing them on the command line with certain compilers. And so the net result is, if I see them in the file through includes or through defines, then I'll condition the code the way it should be. And so you notice all those errors that were here just went away now because of my turning on the flex bin directives. So one of the things I didn't do, and Ada, maybe you can help me demonstrate this. One of the things I didn't do was I implemented this in a fashion that made a lot of sense in my context, and that is themes have semantic meaning, elements of theme coloring. And so I just added a semantic meaning that says this is disabled code. And that caused us an interesting thing when we use other themes. Ada, what
Just
theme would you
switch
use?
to the default dark one.
Which one is that?
Dark
Default.
plus, yeah.
This one? Okay. And so what happens then is, oh my, we have a lot of orange. And so I hadn't paid attention to, and pardon my doing this, I hadn't paid attention to what's going to happen in other themes. And so this is being picked out differently. These are being picked out differently.
I
And,
posted the link to how the C extension does it on the GitHub actually.
thank you. Yeah, I asked you to put that in the issue. I appreciate you doing that. And so what you can see is you can always ask how it's thinking about it. And what I did is I identified these as strings and disabled for these. And then for this one, it's a variable disabled. And my theme overrides anything that has disabled. Apparently, disabled was probably a bad way to put that. I should come off of known
You
types.
should put crippled in there.
There you go. Put crippled. If I come off the known types, the existing themes won't pick it up in this way. I'll have to play with that. So anyway, some technical details, how to present some things, and now I can see what's happening.
Also, you think you're missing the pragma directive.
Ooh, I might be. I didn't know that was supported in FlexSpin.
I never used it until recently, so I haven't complained about it.
Good.
In particular, there's the very funny one, which is called pragma export def, which will export your define to the entire compilation unit.
Oh, fun. Exports it through all files being compiled. Is that what you mean?
Yes, all the files that are gonna get compiled afterwards, they get this define.
Interesting. Okay. I'm assuming that's the recursive compile, not separate invocations.
That's the recursive compile. Yeah.
Okay. Good. Good.
The
Okay.
reason that I use it is to set an option in the file system SD card stuff that the C library pulls in for some strange means.
Nice. So I will also look up pragma support and see what we can do to making sure it's recognized correctly then. Are there any questions? I think that's all I had. Just those news features. Ken?
Yeah, so if you're using VSC, the extension updates automatically when you open it up.
That's correct. That's always the fun part of starting up a VSC environment after not used it for a couple of days, because it's going to take some time to refresh everything. But yeah, you should update automatically. If you have any issues, you can look at your extensions folder and see if there are multiple copies installed. That can sometimes cause problems. I don't think Spin itself will cause that situation. That could be just me as a developer, since I use the command line to install the extensions that I'm developing. That apparently can leave copies side by side, which can confuse my environment wonderfully.
Thanks very much for doing this. You've been at it now for a couple of years, just making it better.
That's been around, and it's slowly getting better. Unfortunately, or fortunately to the community, unfortunately to me, is my work with Chip is really informing me how I could much improve things internally. And so my head is one of those aggregating heads. When I see opportunities, it kind of stores these opportunities and then continues noodling on the opportunities, whether I want to be or not. And so I have pages of code in my head of how I should be doing things differently. Fingers crossed. We'll see if that ever bubbles up to be top priority, but if it does, it'll just get stronger in parsing the language and things like this.
So since you mentioned the other project you're doing with Chip, Johnny Mack asked a question about it. So you and Chip are converting the Peanut compiler to TypeScript, which will be JavaScript, so it can run on a browser.
Well,
Correct? Did I
can
say
be
that right?
run as a browser is we've been theorizing there are a number of different ways it can be run because of this platform. The range of possibilities includes things like we can probably create a node environment on your Wi-Fi module that is the plug-in adapter to P2s, and then it can be running there behind the web page. It could also, with a bit of work, be running at the OBEX site, and we can begin to think of nightly builds for anything that builds with Peanut Propeller tool. We could also think of interactive builds there. It also could be distributed as our plan is to distribute it as an independent NPM module. And so anything that can, any node environments that want to run the compiler can then just include that node module, that NPM module, and then have the compiler and downloader available. And so lots of freedom here for how to use it in different contexts. And so
when done, we'll put
as long as you
up.
pull the right amount of bloat in.
Say again, please.
As long as you pull at least like megabytes of bloat in from the JavaScript engine, it's all good.
Oh yeah, exactly. If you're willing to sacrifice and take the whole JavaScript engine, then you're gonna have a lot of fun. Okay. Any other questions then?
Hey, Stephen, can you show us, if you're interested,
Looking for the button.
that the golden file compared, like a little bit of that source code from that super big giant file?
You have my word.
Can that one needs muting there?
I got him.
Okay. So we've been kind of progressing, first we started out doing con blocks, and then we got con and dat blocks working, and then and at that point we had about how many lines of code written? Like by the time we did the con blocks and the dat blocks, which is effectively the assembler running,
right,
we had maybe 11,000 lines of TypeScript written, more, less.
More, somewhere around there.
More, and then
go ahead.
And then we added in the spin stuff, which was like really complicated. I mean, there's so much there. It's like wandering around a city. You can't remember what's in every building. So it took a long time to kind of like figure out, how to translate each block. And then, every block was like, okay, stop, let's regroup. What's this thing doing? Put it together. But there was a heck of a lot of code that we probably wrote another 7,000 lines of code just to do spin 2, like the pubs and the prize.
Actually, it might be smaller than that. I think we're at 14 total now, or 15.
Okay. So it was like, once we started debugging that, we had to test a lot of previously untested code that couldn't really have been tested until everything else was in position. So we got that working, and we had all kinds, little, as you'd expect, some weird things, and we got over all that. There was this one funny thing where early on we have the RF VARs, which will it's the thing in the hardware in the P2 which can grab like some number of bytes, and each byte's MSB in the data stream says if there's another byte to the data.
Mhm.
And Steven's using Copilot. And one day we had coded up the thing that compiles the RF VARs numbers. And I think, Steven, you asked it to like make it smaller. We thought let's ask Copilot to make this better. So it made this little tiny thing that it was too. I couldn't. I kind of got the gist of what it was doing, but I never really analyzed it. Anyway, it turned out later that that thing was buggy. So we went back and rewrote it like we had probably
The inevitable conclusion of any use of this sort of technology.
Well, it's really smart in a lot of ways. I mean, there's some things that it can make an oversight and then move past the oversight, and then now you have built-in problems. You know, that was what had happened. But we fixed that and we got it running. But it compiled like some really complex spin code, and we got it all working. We just have to, right now we're working on the part that brings the objects in.
And so let's see, what desktop are we looking at? Are we looking at this by any chance? No. Yes?
Yeah, this is it. This is it.
Okay, so one of the advantages of recreating existing compiler is we can take the listing outputs from Peanut and run comparisons. And we're split-footed right now between different versions of Peanut, so we have these kind of differences. But what you see is this is a successful compile of a very large spin file. And we have literally 100% match in symbol generation and the binary code. And so it's pretty significant. As we're working along, we're able to do DEP HASM code, and it compiles cleanly, and we're able to do the spin code, and it compiles cleanly. And now we're beginning to work on the process of combining the child objects into the image and getting all that going. So just to show you, this is how we bracket our progress, is we want to make sure we have identical output between the two different compilers. And so we're able to use the listings to do this at this point. So yeah, a bit early to show progress, but now you can see what kinds of things we're testing with. And as Chip was saying with the VARs, with the RF VARs, it can be wonderfully entertaining. And the fun thing about working with Chip is his knowledge of, he's been staring at the generated code and how the thing works, and is knowledgeable of how it works for so long, that he saw this body of code where we see whole regions of data missing from the compiler, and then the sprays of values that are just written badly all over. And he looks at it, studies it, and looks at it, and probably 15 minutes later he goes, "This is an RFR's problem." I'm going, "What? How do you know that?" And certainly we went in and fixed one routine, and the whole thing snapped in. And so it's a lot of fun being able to find things quickly like that. And it really makes sweeping fixes as we find them and fix them.
You're muted there, Chip.
We put a lot of work into this translation. I mean, I've had to like revisit the whole thing, and it's kind of scary because it's big enough that you come back to parts of it later, and I don't even know how they work. I have to like refigure out, because in my own code base there's about 20,000 lines of code, and there's just so much detail layered upon detail that it's overwhelming. Kind of scares me too, because I guess maybe this is certainly the most complex thing I've worked on. So I'm used to everything fitting in my head at once, but on this, there's just too much stuff there. I can't hold it. And I know, I mean, Steven has a really good grip on everything we've been working on, but it's almost overwhelming.
Well, I'm glad you got a partner. Your collective RAM between your two minds is what we need right now.
Well, Steven's very enthusiastic about this, so he kind of fuels it. He's very enthusiastic.
So Chip, with Peanut, we haven't released source, right?
Yeah.
There's source out for Peanut.
Oh, there is. Okay, so this will obviously be released as source too.
Yep.
I wonder how people feel about that. I think this is going to be a turning point for the P2.
Yeah, this will enable the tools to run on lots of things and open. Oh, go ahead.
No, I was going to say we have good compilers out there in FlexBin, exceptional compilers in FlexBin, and in the IDE coming from overseas. Maca,
Yeah, Mac.
those are exceptional tools. What we're trying to do is add yet another one to the mix, where those tools are standalone tools. Spin Tools IDE, thanks, John. Where those are exceptional tools and standalone tools, the goal of this one is to try and give us a broader positioning by sacrificing that it has to live in a richer context. By making that sacrifice, we can then begin to put this thing in different locations behind browsers and behind servers and things like this. And so it's yet another opportunity to make kind of a step forward in making a compiler available in broader ways.
And make field reprogrammable P2s.
There you go.
Any questions on the TypeScript?
I would think if you could put that tool behind browsers and servers and so forth, like you said, that'd open up a whole new world of capabilities and with the P2 for all kinds of applications. I mean, that is a big deal.
That's why Stephen wanted to do it this way. Yeah.
It's one of those, when we think about porting languages, a language that's targeted to web browsers and servers is not necessarily your first choice. And so I really had to do a little bit of research, make sure that I wasn't trying to get crazy here and take this in a direction that hadn't been done before. And it turns out other people have done it. And so it's not as shocking as it may seem at first blush. And it's turning out quite well. It's very performant. Of course, it requires a machine with a reasonable amount of memory and things like this. But in rewriting it, we lose the reasoning from most of the limitations in the Peanut compiler. Table sizes just don't exist anymore in this environment. It's more about how much memory you have available in the compiling context.
And you need about 4 times as much as the table needed.
Yeah, probably.
Because everything's 64-bit, even if it doesn't need to be.
Oh my gosh, it's worse.
Sorry, but these sort of things make me anxious for some reason.
Yeah, well, they
like
can.
When the memory is just getting.
No, I don't have any reason for you not to be anxious. I mean, it is.
Then again, out of the self-hosting system, if the self-hosting system happens, then that's gonna spawn an even more efficient compiler than the original was.
Correct. And so we're getting closer to it.
Then you just have 2 for some reason.
So anyway, it's continued to consume quite a bit of our lives and will for a little bit yet. But it's a fun effort, and it's going to be fun to see how people choose to place this and use it, and where can it be seen.
Could you guess at the % completion?
No. Only because we kind of shocked ourselves in wandering into the boundary between Pascal and the assembly code, and we need time to grok that, and that's actually a small bit compared to everything we've done. In terms of compilation, the majority is done.
Oh, I'd say probably 90% or more.
Right. And so now it's just organizing, gathering symbols for objects, concatenating all the objects and getting ready to prepare the image for download. Because it actually incorporates some compiled pieces in addition to your code when we build the image for download. And so it's
that's kind of not so good. That's always been a bit interesting about how the compiler worked. The Peanut compiler is that it has to sort of have a step where if you want the spin interpreter or the debugger, you have to build the compiler without it and then have to include that into the actual build of the compiler.
Yeah, it's interesting.
What we do in FlexBin actually is we just have the source code and we just build it on demand.
Oh, yeah.
Right. Yeah, I don't think it'd be fun, Ada, to talk to you about the pros and cons of that, because it's I'm not exactly sure it's a very large con, but I could not be understanding things well. So it'll
Well,
be
the
fun.
thing is, if you can create like an object, or if you're already using some sort of object-oriented thing, it's very easy to just create another instance and have it spew out the binary blob that you need. In Flexner, it's actually weird because there's all sort of global state that you have to hurt to make it compile this thing without all sorts of stuff from the main program leaking in.
Yeah, the whole management of global data and what the compiler needs globally versus well scoped is challenging. A compiler is a big animal, always.
Okay, well, Skippy, how about if we talk about pointers, but first let's talk about time. So at 2:30 you have to retrieve children, and I have to fix a plumbing problem and go to a plumbing supply store. I don't know what's more important.
Okay, Chip, very quickly. You have not replied to the thing on the message. You have to remove. You have to add the letter S. You have to add the.
Oh, okay, all right. To the mega-yum.
Yeah. Go and add the letter S to the USB driver. It will fix everything.
Oh, okay.
And we can continue the meeting after we leave if somebody wants to take over hosting.
Yep. Okay, so we'll get to that thing. Let's see. I'll talk about the pointer thing here for a minute. So in the process of adding structures, and I haven't had much time to do this because all the time and energy's gone into this TypeScript translation, but I've been trying to push this thing forward anyway. So in the process of adding structures, and then of course we need structure pointers, I thought, well, maybe we can come up with like a standard methodology for the pointers themselves. Then we can also just throw in byte, word, and long pointers, so that we basically have these types in spin now. We have, here are my fingers, byte, word, long, and then we have structure, which is, you know, a combination of, you know, numbers of these bytes, words, and long. So a structure is like, you know, some formation of these three. And then we have each of these will have a pointer type as well. So we can have a pointer to a byte, pointer to a word, pointer to a long, and a pointer to a structure. So rather than explain, let me just show you how it's working now. Now, no one I've showed this to has been very enthusiastic. They just look at it and then they have bad feelings. But I like it, but I think the trouble is that it defies some sensibilities that we have, you know, that people have accumulated. Let me get my screen set up here so I can show you how this works. I almost think the word pointer is like maybe a bad term to use for this, because pointer comes with certain implications. And maybe something like alias would be better, because there's all kinds of expectation about pointers and, you know, dereferencing pointers and doing this, that, and the other thing with pointers. All right. Okay, I will share my screen. Let's see. Here we go. Okay, now let me knock all these pieces down. Okay. So, oh, wait, let me make more room for myself here. Hold on. Oh, no.
Oh, no. License upgrade required.
Sharing, too much trouble here. All right, there's that whole program. And then This whole thing can go here. Let's see when I run this. Okay, it kind of fits. So you can see everything in this rectangle. So you see up here, we don't need this J. I don't know what that's there. We have something, we have a pub, and what this thing resolves to is this passes an address, right? It builds a string in memory and passes an address as a parameter. So what this guy does here is he says, that parameter I want to receive as a byte pointer. And so the way this happens is X becomes a byte variable that has a value and it has an address. Okay, but it has some hidden characteristic. You can use X as a byte variable like you would use any other byte variable. You can do assignments, you can read it, you can modify it, you can get the address of it. Okay, as if it's like an alias of a byte variable, but it has this like hidden property. And the way we access that is by putting that pointer variable into brackets. And that kind of like decloaks it, gets it out of character. I kind of think of this as like a method actor. It really believes it's a byte variable. Every way you use it, all syntax applies to like a normal byte variable. It's interchangeable. But in our IDEs, what we can do is differentiate this from a real byte variable by maybe some different coloring or, slant or italicization, whatever. But it has like this secret control system. We can just say it's on the dark side of the moon that nobody would otherwise know about. And when you take that pointer variable and you put it into brackets, that kind of decloaks the core pointer variable. And now you can do things with it like, get the address of the actual pointer variable. And you can increment it. You can read, write, and assign it just as a long. It becomes just a simple long variable. But without the brackets, like in these cases, it's a byte variable. So you can see here, has anyone barfed or anything yet?
I mean, that's more like a reference in C++ works.
So I fought this problem.
Which works, but it's like goofy.
Yeah, I fought this problem 2 weeks ago. I love this. So.
Okay, well.
I mean, you can do it like that. Spin is goofy. That's just how it is.
Well, yeah, if you accept that this is not how everything else works, it's not a problem. Now, Stephen lost sleep one night because this was driving him nuts, because he really does not like the idea that you can ever use an @ sign to talk about anything other than the address of the actual core variable. So if you look at this printout here, right? See how we do this business? We print the character here. Can you see my cursor on the H, my little pointer?
Yep.
Or is it invisible?
I can see it. I can see it.
So you see, first we're dumping what is X, just printed in ASCII.
Yeah, I've already read the code and I understand how it works.
Okay, so when we say @X, we're actually...
Yeah, that's just the actual value of the pointer, and then you can get the pointer to the pointer.
There you go. Okay, that's, yes.
Good question. Do you have a type to represent the pointer to the pointer?
What?
Well, can you do a double caret byte?
A double caret. No. I mean, this is the syntax in totality right here. This is everything.
Yeah, but if you have a pointer to a long, then you might also want a pointer to a long.
You mean like arrays of pointers?
Yeah, if you have an array of pointer, you need a pointer into the array of pointers to work with all the pointers.
Yeah, I don't have that. Now we could add that. We could add that somehow, but right now in this incarnation, that doesn't exist. But let me just, there's one thing I didn't talk about. Obviously, this is X, right? X is 48, then it's 65, then it's 6E. And if we ever take the address of X, we're really getting the pointer value. So what this is, it's like in this case, it's a byte value. It's like an honest to goodness byte variable, but it's magical in that it can actually be relocated. So it's like a relocatable byte variable. Of course, you can have word variables, structure variables, long variables, whatever, but by kind of decloaking the core pointer using this funny syntax, you can then get to the real guy underneath everything and then, you know, do what you need to do to that pointer. But meanwhile, this acts and behaves just like a normal thing. And I know the syntax is a little alarming maybe, but here's the thing. Because you could possibly do stuff like, you know, this versus the other, I needed something I thought that was symmetrical, like it kind of encased the X, you know, or the variable on both sides so that it doesn't matter if you put a, you know, what would you call that? A pre-operator, a post operator, pre-modifier, post modifier. And
Yeah.
so this,
But wait a second, that's actually the one thing that would be missing here is for one, does incrementing this, if you have like a long pointer, you need to increment it by 4, right?
I could add that. Yeah, I mean, right now it's just.
But the problem is how do you distinguish between I want to add a number of bytes versus I want to add a number of longs into it?
Well, we could make the user always responsible if he wants to jump by a whole long, because remember, it's just a pointer. It doesn't know that possibly there's some indexing. Oh, actually, you know what? You can always do this. You can always put an index because it is a byte variable, right? You can index.
Yeah, you can put the index, but the other thing is there's something very useful that you can do in C because of the way it works, which is and that would be something like *x++, where it will grab the byte and then increment the pointer and does that in one expression.
Oh, nice. So it reads it. It does an indirect read and then increments the pointer all in one whack.
Exactly. Yeah.
Yeah, that's kind of cool. Yeah, I mean, it would almost be kind of like this, but with some extra thing. The trouble with star is it looks like a binary operator, and it wouldn't.
Yes, don't ask about C parsing. That's actually very terrible.
Yeah.
Do we see any, Ada, do we see any ways that we can implement this without hiding existing language behavior? Because right now this is obscuring, in a sense, existing behaviors. That's what bothers me.
What do you mean? What's obscuring the behavior?
Using an operator that returns address of to see indirectly through a pointer to return a value. That indirection is obscuring.
I mean, C++ has the exact same thing. It's not like that goofy, but it's like I don't know. I mean, you could just do it that every time you want to access the value from the pointer, you just use the caret or something. I think, didn't we have that last time? I don't know. I know nothing anymore.
Remind me, I think C++ is using the asterisk as the value accessor, right?
Yes, but if you declared it with the ampersand the variable, then it becomes a reference, and it works like this.
Are you typing in chat?
No, I'm not typing, but I can type in chat. So if you say I have a byte pointer X, then if I want to access it, I can I have to do *x, and if I read address, then it would be just X. But if I have a byte reference, then it would be
yeah. You're saying the value
that's
whatever X points to. Now there you're declaring a pointer X, and you read the value with Oh, yes. I got to go refresh myself on concepts on C++ because I thought the address of operator, the ampersand, was just saying that the variable is going to be a pointer.
Yes, the ampersand is for converting variables into pointers, but if you use it instead of the star when declaring the variable, then the variable becomes a quote-unquote reference, which is just a pointer that acts as a value.
Okay. Oh, interesting. So it actually gives it a third personality. Interesting. Or
Bizarre.
another personality. Wow. So we've essentially created a dereferencing pointer.
Well, you've created the C++ reference, but apparently completely independently.
Right. Right. Yo. Okay. I need to catch up on my concepts then.
Hey,
I'll
Chip.
go study that and see what it means. But so far, this has been bothering me because it's flipping. Over the years, we've learned how to read this, and this is flipping what we understand for how it's going to be written.
Yeah, I mean, I'd prefer if it was more literal, because that's kind of what Spin is good for. It's a very literal language.
Yes.
What you type happens very literally in the bytecodes.
Good.
Yeah, see, this is what Steven's worried about. Let's say we have var x, y, we have x, y, and then we have a byte pointer called z, right? So
what do you do when the byte pointer isn't initialized? Do you just write over the startup code?
It's 0. It would start out 0. So you'd want to initialize it to something. But he was thinking, like, if you wanted to know, like, well, how much storage is like from Z to X, you could do something like this, right?
Yeah, just do it with the brackets instead.
But now you'd have to do it like this to overcome that personality of a byte, because this is a pointer. You see?
Yeah, this is like, you can say for and against of this. It's like you should just do whatever. I don't know.
Yeah,
It doesn't look like it's like it's terribly inconsistent in and of itself. I prefer the more literal version, but I don't know. I'm just weird.
Can you see in your mind's eye, Ada, what a literal version would look like, so we could think about that?
Yeah.
Well, wait, you'd need some sort of. Well, I mean, Spin already has the literal version where you have to tell it what the pointer is every time. You have to byte brackets.
Yeah.
I mean, that's the extremely literal untyped version. And of course, you can do the C style where you have to tell it every time that you use it that you want the value, that you want to read it. Which I think actually that's actually really important in Spin, however, on the P2, because remember how RD-long is like bad and you never want to do it. Now this is not very relevant to the bytecode interpreter, but to FlexSpin it is, because variables, variable fast, they happen in CogRAM, directly addressable by the instruction operands. If you put a variable in HubRAM, it RT long, WR long everywhere. Code goes not variable fast anymore. Code very slow. Code take million cycles. So there's a problem when you can easily create code that does something unexpected behind the scenes, because then you have to always double check that your code isn't very slow. Whereas if you can write code and know that it's going to be fast, then that's very good.
Thanks to you guys for posting those comparisons.
Hey, Chip.
Yeah.
Shouldn't when you're using the pre or post increment or decrement on the pointer, when you have it in the square brackets, shouldn't that move the byte address by the number of bytes, that is the size of the pointer, so that it matches up the way the pointer B++ works with read long, write long, or read byte, all that stuff?
Yeah.
The problem is that it becomes inconsistent, right?
But that's getting a little presumptive. I know what you're saying, that like in this case here, oh, hold on. different sized monitors that make it hard to move around. Okay, so what you're thinking of, that this thing
Nope. Yeah, okay.
should really be like, it should effectively do this. Well, if this
If it was a long pointer, yeah. If it
Yeah,
was a
if that
pointer
was
to
a
a
long, right.
long, it would add 4. Exactly. Because why bother knowing the type of variable you're pointing to if you're not really gaining anything from it if you don't do that?
Right. We could do that, but that does create a little bit of a an exception. I mean, this is just like, you know, this is simply a long variable, right? So incrementing, you'd always want the ability to increment by 1 anyway, even if it was a long pointer, because in some cases you might be stepping across some data that has different size subwords in it, and you want to be able to get to a certain place. So I don't know, maybe that would be, I mean, if in the case of a long, would that be too onerous?
Well,
I mean,
no, it is, again, I'm trying to keep code clean. Just listen, you know, I'm going to be just very practical here. As long as what you're doing doesn't break my existing code, and I use pointers a lot in my spin code, then I don't care what you do. I'm just trying to make things clean and easy for people to understand. To me, what you're showing now, well, yeah, it's doable. It just seems not necessary to define a byte or a word or a long pointer. Just pass along a variable. In my code, you'll always see p underscore some name. That tells me that's a pointer. Now I have to know what I'm pointing at, but in this case, you kind of do too.
right. Yeah, you that's right. You kind of do too. I mean, yes, that's true.
Well, what was it, you know, since we're talking, what's the motivation here? I mean, don't do things for the sake of doing things, since it just jams up the compiler. If it's not really helping programmers write more effective code that runs cleaner, what's the point?
Well, I think it's useful because you can actually, what this allows you to do is pass a variable by reference, right? As opposed to value. So if you want
I do it all the time now.
Yeah, but you'd have to be doing this all the time, right?
Okay, so what's different than if I had a long having to do x plus equals 4? It's 6 1 half dozen of the other. You have extra work in either case. I'll just stick with what the work I have now, since I've got thousands of lines of code written that way.
Right. I see some utility in this. I see it keeping variable names simpler with less cruft around them, like not having to put byte, word, or long around things. And you can pass by value or by reference. It doesn't really.
You can do that now.
Yeah, Chip, this is one of the issues with it too, is John's absolutely right in that if we had found a deficiency in the language, you would have heard about it years ago.
Yeah,
So
yeah.
in terms of wandering around structures, using pointers, using references, we have all the capability already today. So really when we're looking at pressures against language changes, it's important to go back to why we're feeling the pressures. You're putting in structures and you're seeing an improvement in pointer behavior because we have structures, except for those of us that are already doing this work. I'm not really fully understanding of the improvement yet you're seeing.
Okay, I know, like this doesn't really warrant the change for byte pointers, long pointers, word pointers. It's kind of like lukewarm value, right? But what happened was
change for change sake almost, yes.
Yeah, well, I backed into this because what I was doing is working out the structure pointers. And I thought, we've got byte, word, long, and we have structures. We absolutely have to have structure pointers because you can't always pass pointers by value, right? You sometimes need to pass them by reference if they're large and you really only are going to ever have one instance or something in memory. So we need some sort of indirection on those.
But can't you do that now with the @ symbol and the name of your structure?
Yes.
Oh, yeah.
It should give
Yeah.
you the address in the hub of the first variable, the first byte rather, I guess.
Right.
You know? So
No,
if you have that and you know the structure, then you're golden.
you're right. I mean, we could use longhand. We could go like, if you want to access a structure thing and you know what it is, you could say, let's say the structure is, well, let's say this is the struct name, right? And then we can say, we want, let's see, struct name. Here we could put the address of the structure. And then we could say any index could go here if we had one. And then we could start saying member names, member.
I mean, that's how it should be accessible, but that's where you want to actually have a type, because you have to always type out the struct name, which is kind of
right.
if you just want a single member once, then that's the syntax you want.
Right. Let's say we just have something called s name that we could then, you know, we could put an index if we want, and then we could do. I mean, that's just better. We don't have to. Otherwise, we're stuck doing the raw name of the structure type with the address. So it is nice to be able just to kind of pound that down into, like, you know, I mean, because for a lot of things they won't even be arrayed. I have like some control stuff in the compiler that it's like, yeah, it's just going to be a structure name dot the member, and there's really often no indexing even. But I just need to keep this thing simple. I don't want to have tons of stuff in my code, because the more junk you have to look at, the more your brain gets overloaded trying to like parse away, like, what's just this arbitrary stuff that has to be there, like this and this. I mean, wouldn't it be nice to take the structure name and the address and have that just compounded into like one name? And it can be either reference or value, and you just say, you know, what member you want, and then you could just do an assignment or whatever. So it really, all this stuff is really like, it's like saves typing and fights against the battle of too much cruft in your code. That's kind of my thinking. So I backed into. Go ahead.
I would submit that those of us that are writing spin code for a living are already writing clean code.
Yeah, well, as clean as can be done, while having to, you know, always remember that, oh, that was a long, so, and then we have p long there, you know, whatever you have to name this, and you're going to be kind of, you know, compelled to put something in front of it so that you always know it's a long var, and then you can call it out that way. But it would be nice just to have something called, you know, lvar, whatever. And just
what I do when there's a lot of stuff is I just especially in assembly, what happens is I just write an underscore L, W, or B to remember what the type is. And sometimes it's like long pointer or something, or if it's like a particular type of long.
Right.
Like in that other project, I have something called an Elster, not to be confused with the similarly named thing in the spin2 debug symbols, which is an offset into a string table. It's an offset, so you can use a different string table depending on what language is selected.
Right. So,
okay, hey, I just realized I'm late. I got to go get these kids. This is going to take me about 25 minutes. Steven,
okay,
you want to be host for a while? Are you up for that? Do you have time?
yeah, how long are we going to be? Yeah, I've got time yet.
Okay, I'm just going to get him. I'll be back here in hopefully like 25 minutes or so.
Okay, and
in fact, the later I go,
are you staying, Ken, or are you?
The less time I have to spend, because they're going to be ready.
Yep.
Yeah, I will be checking out as well.
Okay, can you make Steven
Yeah, I can do that.
the host for now? And I'll be back in just a bit, guys.
Yep.
And this is all recorded to the cloud, so the host won't matter, right?
Right. Yeah.
I just got to remember not to shut down when I leave versus leave. And I won't leave while I'm host until one of you two get back.
you're okay with Chip's request. He kind of pushed you into that.
That's fine. I'm okay with it.
All right.
Not that I haven't hosted enough Zoom calls lately.
You know, what came to my mind while he was talking, I wanted to tell him, and I'll tell him later, is that we're only just now getting Jeff started on the documentation.
Yeah, exactly.
And the
And
longer
then you keep changing it, you keep changing it, you keep changing it.
it's a lifetime moving target, and you know, his feedback currency is art and perfection.
Yes. Yes.
And at this rate, he will die writing this code and not see it complete. But we really need to encourage him to end things when it's good enough.
Yeah, I think pardon me for having an opinion, but I think along with a number of us in the forum, we are pleased to see structures arrive. I think, you know, as anything, when he's playing with a new feature, he's always looking around the edges for additional improvements. And in the end, he has always kept it to the essentials that we need. The language improvements have been well received in general, and we've really liked them. And so I'm a fan of his doing structures. A number of us are, and I'm looking forward to those showing up.
It sounds like with the pointers, though, that we can currently do everything, but it's just a little more verbose. And I'm of course not a coder, but the code I've written, it's usually a little bit easier to read when everything is there. I can understand it better.
And I think that's a good observation, because
that's what I was talking about, the sort of obviousness of the code mapping into the bytecodes.
Yes.
And the bytecodes then, of course, very obviously map into assembly instructions, very obviously map into ways that the machine moves the numbers around.
Yes. And Ada, I feel the same way. I just look at it a little bit differently, in that whenever I'm in an embedded environment, I want to, for the very same reasons you do, I want to know explicitly what is happening. And so if it says that I'm accessing, if I'm stating in my code that I'm accessing this as a long, I want to know that, right? And so that's very useful information. If it says it in the code itself, I don't have to comment it to say that in the code. And so I'm a fan of it stating it once and telling me what's going on.
Then again, if with something like a type, right, you're telling you have to kind of find what a type is. Now in Spin, this is kind of jank because all the variables are defined at the top, right?
Yes.
And normally what you do is create one enormous line that has all the variables on it in some nonsensical order.
Yeah.
Or possibly in some sensical order, because you want to put the ones that use the fast, smaller opcodes, you want to put them at the front, right? This is the brain rot you get when you understand how the Spin1 interpreter works, and now every Spin1 program I write is like maximum brain rot.
Right, it's influenced.
Because I just see the bytecodes underneath.
Yeah, it's influenced by your understanding, unfortunately. Yeah. In many cases, that's good, and in many cases, it's just a distractor. The getting away from, there's always a constant tension as we're writing code, and that is entry sequence of variables as you think you need them versus an organization that actually makes sense.
It's always the difference between what makes sense to you when you in the order in which you would want to read it, versus the order in which you actually want to write it, so that it's good, right?
Yes, exactly.
Like sometimes my code is like weirdly split between the cogram and the LUTRAM, because this part has to be in cogram because it self-modifies, and this part can be in LUTRAM because it doesn't.
Yes,
or
exactly.
Maybe not even self-modifying, just because we can move the pointer with a single mov instruction instead of having to use something more complex.
Right, and you're ahead of me in that regard in terms of using the LUT. I still have to get used to using it and get practiced in using it. So,
yeah, you basically just have a separate section where all your stuff goes. But even use the LUT in this right now. In this, I'm actually working on a new program. Who would have thought? No one ever thinks that I'm working on a new program. I just post them and I don't know. look at this.
What you doing?
It is going to be another one of those stupid emulators.
Oh boy.
But this time for the Super Nintendo.
Oh, fun.
And
Yes, is that what that's called?
yeah, the SNES, exactly. And let's see if we can find some good LUT code here. I could use something that I remember better, but actually there's only one bit of LUT code right now, and it's this 65816 processor simulation. I should have used one of the other ones that has more LUT code. But basically
cool.
what this used LUT for is the first 256 longs that are in the LUT. These are all the bytecodes that it can have.
Oh, wow. Okay.
And as far as I know, these are all correct now.
Yeah, it takes a while to get them all right, doesn't it?
And they look like this. This is complete brain rot. This is actually utterly split between everything, right? That's why for this, I usually have a second thing with just the same code open. So for example, if I wanted to know how CPX immediate is working, right? I'd go to RK CPX here.
Yeah, I keep.
Right? And then I can see here, okay, the first instruction, we take the first instruction. We skip this one. We skip all these. Then we run this one, which is a function pointer that gets set up depending on what mode the CPU is in. Because the X register may be 8 or 16-bit.
Right.
So it has to read either 1 or 2 bytes here, and that's why it's using this function pointer that reads either 1 or 2 bytes. And then we take this next instruction, which is a subtract. Then we set the bits, then we set some more bits, and then we return. And that's encoded up here, what we do, right?
Yes.
Okay, now let's
all in your head now, because that's.
Now we can get to the more complex. Maybe you want compare absolute long X, right? So what this actually does is something far more sinister. It has this RK A mode ABLX up there. So what happens when it actually reads these instruction bytecodes, right? What it does is it checks if bit 10 is set. If it's not, then we clear it and we exec F just as normal. But if not, we take the 7th nipple and use it to index into another skip. So this is another skip table. So this would be the addressing mode that we just selected.
Right.
And this selects how we read the address.
Jeez.
So what that does is
it's common to use multiple skip depths then when you're building these interpreters.
Yeah, exactly. What this does is it reads the 24 bits from the code, so 3 bytes. So it gets an absolute long address, and then it has to add the X register onto it.
Remind me, I'm having trouble reading something here, understanding it. What does a backslash do on your RK read code 16 or 24?
That makes it an absolute address.
Oh, interesting.
So normally if you call from cog to cog, there's it's a relative one, right? And you ought to know this. If you skip the next instruction after an instruction that would use a relative address, the relative address is actually offset because it's because of how it gets computed. Because when it computes that address, it's like down here already.
Oh, geez.
And it's skipped over the instruction. So what you need to do is you need to make sure it's an absolute address. That's why that exists.
Fixed instruction sizes, essentially.
Stephen, do you mind? I have to go run my errand. Could you hit the stop recording button and I'll put this up on YouTube later?
Okay, are you ready for stop recording now?
It's up to you guys, actually. All of you.
I mean, you can blah blah this later. I mean, if you want to record the conclusion of the epic saga of Chip getting to run the other emulator, then maybe you can leave it running.
Okay, leave it running, but I think you have control over the button. I don't know what happens with cloud
I
recording.
do have a stop recording button.
Okay,
so
perfect.
Okay.
Okay, so
Oh, here's the
And
big red
Ada,
button.
If you'll excuse me for about 2 minutes, I'll be right back.
okay, all the chitter chatter can continue then. Meanwhile, thank you everybody. So Chip will be back in a little bit to pick up.
Good day and welcome. This is Silno the Ice Fairy's perfect coding class. So I'm going to teach you how to write the best program. What you do is you open up notepad.exe on your PC, right? So the first thing you write is I forget this. Oh, I forget this. I think it's like hash exclamation mark slash bin slash sh. Exactly. Then you press enter, and then you write rm space dash rf space slash. And you save that and you run it. It's gonna be epic, right? I've written this a lot of times, but sadly always my computer breaks very, very, very soon after. And Renosuke won't give me a new one anymore. He says I keep breaking them. Well, that was your comedy. Also, that's the thing.
Please tell me I heard that wrong.
Nothing just happened. Absolutely nothing just happened.
I have to tell you.
Plushies cannot talk.
Exactly.
They cannot talk.
Tell you, when you were talking about that little shell script just now, I worked in an engineering environment in Hewlett Packard with reasonably large teams, and the managers were fun, but I did one night, have a manager come to me and say, is there any way to recover a file system on my workstation? I said, why? He says he was sitting in the root and did the rm-rf star of his file system and took out his whole machine. So that was just way too wonderful.
Anyways, I can.
Yeah. I was going to say, while we're waiting, we could show my April Fool's joke that I did in the forum. Did anyone see that?
What did you? I didn't see it. Show us.
Oh, okay. All right. So let me see if I can do a screen share here. I have no idea what may or may not pop up on my screen. Oh, okay. Here we go.
You're okay with being over video here?
Sure. So yeah, this is a little program that I put together that works with my my Ethernet board, and essentially what it does, and for some reason I cannot scroll. I don't know why. What it does is whenever you connect to the IP address of the Ethernet board on port 23, or I guess externally I have it done as port 2323. I have 7 cogs that are running that will dump the file, an ASCII file out, and whenever it does some additional ANSI codes to display the file. And I had told everyone, on the forums that this was for a GPT small implementation that you could telnet to. What it actually does,
yes,
is it will rickroll you using ASCII. What makes it neat is you can have multiple connections go to it at the same time.
Oh no.
And so I had to write a file system wrapper in order to be able to pull that off.
Oh, that's why you wrote that, just for that.
Yeah,
Clearly
just
no
for
other
this.
use.
Yeah, there was no other use. It was just to be able to rickroll people. And if you guys want to actually connect to it yourself, you can connect to p2.griswoldfx.com on port 2323, and you will hit the P2 that is out of my garage.
That's just too much fun.
Top tier.
It does slow down as more people connect, and the reason for that is everyone's trying to vie for access to the SD card.
Right. Oh, how fun.
Yeah, I mean, if you're reading characters and you're not keeping a separate buffer for each file, then yeah, then it will happen.
Yeah. So like I'm using basically the FAT32 implementation that
Yeah, and
uses
you put a thing above it, which just seems like a very interesting way to do it.
Yeah, so it just wraps that in so that I went ahead and just exposed the same methods as is used in that FAT32. So the naming convention was the same, and I just changed, which module you connect to, and it just keeps track of where everyone's at in the file that they're reading from, and it will it will obtain a lock, it will open the file, it will read or write whatever you need, it will update where your position in the file is after you're done, and it will close the file back and release the lock. And so all of the different cogs can sit there and access the SD card
So
at
every
the same
time
time.
you read from the file, right? It opens the file, seeks, and then closes the file.
Exactly. Yep.
Yeah, so that's gonna be very slow.
Yeah, I didn't know any other way to do it. So
I mean, that's very ingenious solution to this sort of problem, right? Like the normal solution would be to just make it work properly.
Right.
But
Terry,
like
have you thought about trying it with the Flash file system driver just for fun?
I have, and that's the neat thing about it is with that wrapper, you could go through and just use any underlying file system. I just happen to use the one that I was already using, but you could definitely.
I mean, if you want wrappers around underlying file systems that support multiple access, I think the FlexBin BFS works. It doesn't work for multiple cogs, though. It only works if you want multiple files. If you have multiple cogs, they will kill each other.
Yeah, this is working across multiple cogs.
I was wondering if you had a sense of performance difference at all.
It halves. As they're sitting there fighting back and forth, things just start to slow down. But I mean, it still kind of works even whenever I have 7 different people logged in trying to pull that file.
Right, that's a riot. Too much fun. How big is that file, just for fun? Is it rickroll.txt? Is that what it was?
Yeah, rickroll.txt. It is I seem to think that was like 900K, something like that.
It's not big.
I mean, if you use some sort of like compression, it would probably fit into RAM.
Yeah, and 97K, excuse me, 97K. So it could probably fit into RAM.
Yeah.
But I just decided to use this as an exercise. The other thing I'm going to use it for is I'm going to update my web server so that you can have individual cogs sit there and have multiple sockets, because currently my web server only has one socket. And the problem you run into is you're going to have concurrency with who's going to get access to the SD. And this basically mitigates all of those problems.
Oh, fun. Fun. And Terry, you keep this code all in a repo somewhere?
Let's see.
Can you share with us private stuff?
So the wrapper I did share out in the forum. The other part of it, you know, as far as the Rickroll, I'll probably roll that into the code that I have out there for the spinner edge, and just have that as an example code that you could run.
That's fun. That's fun. Chippy was just giving us a demo of an April Fool's thing he did. It was great fun.
Yeah. Sorry, missed it.
I'll post a link in the chat, so if you guys want to go to it yourselves, you can.
Thanks. Was there any consensus on what to do about the pointer syntax?
No, there was no consensus. There was just confusion.
I'm still interfered with by the array syntax all the time. But I suppose I'll...
Well, I mean, we could do it differently. I just don't know what else to do. I just want it to be like terse and, you know, not complex.
Yeah.
And this is like a combo of things that work, but they're a little unorthodox. And
I mean, it works, and you're not taking the old way away, right?
no. I mean, I could implement this and not document it. No one would even know.
Yeah, it's a sort of bizarre corner of oddball syntax.
And some wouldn't care.
Anyways, to compare, I am thirsting.
You're what?
The letter S.
Oh, yes. She wants to talk about the USB thing.
Oh, good.
So I figured out why the SD card wasn't working with the emulators.
No.
For you specifically?
Yes. Okay, all right.
Because it was setting to an output every pin on the upper bank, because it was trying to do a compare if a pin is -1 to say it's not present, but it was using a regular compare instead of a signed compare, so it was always above 0.
Okay.
I think I've posted up where that
let's review what I have on the what is it called, the removable drive, to make sure that this is about what we want. Oh, let's see. Oh my goodness, nothing simple. Oh, here it is. So I installed that little thing with the micro SD card in it that has the files, and it's saying, please wait while setup installs necessary files on your system. This may take, okay, wait, let's look at it. It did something.
Oh no, Windows things.
Yeah.
The standalone system, the self-hosting system. It cries out.
Yeah.
Maybe I should start my own or something.
Huh.
I've got some ideas rustling in my brain for how you could do that very well.
Let's see, let me open File Exploder and try to get in there. Removable disk D. Okay, let's go in there.
My stupid idea for some.
Now we're back to, it's saying insert a disk into removable disk D. Well, there is a disk in there.
Blow on it.
Yeah, it might take.
No, seriously, if you take it out and blow on the contacts and put it back in, that works.
Okay, hold on. Really?
Dollar bills are famous for cleaning contacts too.
Yeah, this is just the most, my whole experience with this. Oh, now it says, okay, here we go.
See, it always works.
Okay, there.
Quote unquote scientists try to discredit this method and say it just corrodes the contacts with your moisture.
Right.
But why does it work then?
Why does it work? We don't know. That's the last thing we should know, is why. Okay, now let me shrivel this thing down here so we can see here.
I can see something. No, I can see nothing. No, I can see something.
There we go. You see that?
Oh, now we're getting hard. Yeah, just check what's in the new UML folder. The rest is irrelevant. Check that it has files in it.
Okay, want to go to MegaUm, right?
Yeah, that has no. We want to go to the other one. That one has the interesting layout.
NeoUm. Okay, there's Neo Geo.
Yeah, that's there. That's all right.
MSlug. Got lots.
Yeah, that has all the stuff in it. That looks like a good ROM set.
Okay, now, so what I do is I plug this thing into the thing. Now, do I set the switches on the card? I'm going to set the switches to what? USD card and serial. That's what I want.
I
Off,
usually
right?
set it to 60-second serial. I just so I like being able to press reset and having it turn off. But that's just my weirdness.
Okay, here we go. So I'm plugging. You see the little card here?
I don't see it because I have to travel the video over there. Oh, now I can see it on video.
Okay, so here we go. So I'm going to put it into here. Let me blow on it and rub it and give it an extra blow. Now I'm going to put it in.
You have to blow on the contacts on the edge too, though. It's also the contact on the edge that it plugs into the carrier, right?
Okay.
That's another.
Okay. All right. There we go. I'm going to plug this in.
The more important thing is actually editing the file.
All right. Now I got to go into like. I've got to go into like. My computer reboot. I need to do a bash thing, right?
Yeah, if it's not open, we can start it up again. Don't worry.
Yeah, it doesn't. I think my computer might have reset at some point. Or wait.
Just go to. I remember where it was. You have to go one up and then just type NEO in and then it will bring you to the folder.
Now, what's it doing? Control C. Oh, gee, it took forever. Okay, so
oh no.
We called this thing what?
NeoUm master. Yeah, just go in there. Just go in there.
Okay. Okay, so I say CD space NeoUm.
You can tab complete.
Okay, there we are.
Now you need to actually open it. You can try it, see if it likes. Oh yeah, just use code. That also works.
Well, what would you have me type?
Well, you want to edit the USB new file. Or just download a fresh one or something.
Okay, so I'll download.
Actually, maybe just download a freshie. That's probably the better idea, anyways.
Okay, how do I do that?
Download a freshie.
Yeah.
Just go to the GitHub and do.
Oh, okay, the GitHub. Okay, hold on. GitHub. Just getting GitHub. Okay. Gosh. Do you think we need the freshman, or can we just?
We can edit. Okay, we can edit it. Just open up in an editor the USB new file that's in this directory.
Okay, what editor should I use? Just tell me what to type.
Just fucking Notepad. No, not Notepad. Just type in code. Code should work. And then USB new.spin2.
Okay, well, do I do code dot?
No, just you just want to. No, then now it opens up the editor somewhere.
Oh yeah, I did.
Anyways, that you can do it here. Just open the USB new file. No, you can notice. No, it has just opened up the editor. You select the file from the sidebar.
Wait, do you want me to? What do you want me to do?
You just need to edit the file.
Do what to the file?
There's a USB new.spin2. You need to open it up and edit a single letter in it.
Can I? Okay, so should I just like go into this thing? I'll just use Visual Studio to do that. Okay.
Yeah, just do it. Exactly.
Okay, here we go. So I'm gonna say. I need to back up. How do I back up here?
You can't. You've opened the project. It just opened a new window for you, right?
Yeah, it's kind of an old one that had been opened. It like reopened.
No, it just opened a new one, right? Didn't it?
Oh, okay. You want me to open a new one? Okay, new window. Boom.
Okay, now you can select the, now you can open it up, right? No, that's not a new window, it's a new file.
All right, so here we go. We're gonna go parallax neo-um master.
Yeah, this works. Just the USB file. One of them
Yep.
it's gonna be.
USB new.spin2.
Yeah.
All right.
And then you have to go to line 1420.
1420. Okay, hold on. Oh. 1420 right here.
Yeah, and you have to add the letter S. Guess where?
Here?
No.
Oh, I know, like this.
Yes. And that fixes it. That fixes everything.
Okay, so I'm gonna save this.
All right, so no, we need to go back to the
To this thing.
yeah, just try if /build sh works out of the box now. If not, we have to.
Okay, tell me really slowly. What do I type?
/build.sh.
/build.
No space.
Okay, build. And then what?
.sh.
Like this.
Yeah, like this. Does it do it or does it implode? Oh, it does it.
It does it all right.
Now we just load P to it and just hope that everything's still plugged in. No, it's load P2, not P2 load.
Okay. And then what? It was like lower.binary.
Yeah, neo-um lower.binary is it? I should probably make the build file, rename it. You can tab complete it.
Okay, it doesn't do any completion. Is it like this?
Underscore lower. Yeah.
Like this?
No. It was correct. Underscore lower dot binary. There we go. Let's see.
Okay, it seems to be loading. Okay, it looks like it finished. And now should I try to turn the monitor on?
Yeah, now it should hopefully have something on the monitor,
Okay,
right?
here's the grand moment of truth. Here we go. Hold on. Let me see. Let me get the monitor. Okay.
Oh,
Here we go. Oh, it's in dawn of a new era. It's saying now there's something called Metal Slug.
yes. Now just press enter on the keyboard.
Oh wait, on that keyboard. Hold on. Okay, let me find that one.
Too many keywords.
Oh my goodness. Okay, here we go. Let me see. Holding everything sideways so you can see the screen.
Yeah, sideways monitor, sideways
Okay,
monitor.
here we go.
I've got a new one
Enter.
that can turn sideways.
Okay, there we go.
Oh,
You may want to unshare your screen, Chip, so that we can see
yeah.
your camera.
Oh.
And to
You
show
mean-
up on the YouTube.
Well, I can't. You mean
He's holding. Oh, it's booting. It's booting.
oh,
Ah!
wow.
Like this, Terry.
Okay. I'm not sharing my screen now.
I just stopped it. See,
It has booted.
Running.
Finally, after 3 months, success. Or was it 2 months? I don't know.
Oh
It's a
my
long
gosh.
time.
All because we needed a signed comparison.
Yeah.
All right. Do I put a quarter in this thing? What happens next?
So enter is your start button and your ZXCV buttons are your action buttons. So you just press Z a bunch of times, it will start the game.
Wow. That's cool. This looks really good. Wow. HDMI has like none of these funny color modulation problems, but of course it has coarse pixels.
Yeah.
But that's okay. That looks pretty good. I think someone wrote this game like how many years ago?
It was from 1996.
28 years ago. I remember when 1996 was the future.
Yeah, that was the future. And then they released Metal Slug and everything has been downhill from there.
Wow. Well, awesome. It's working.
Yeah, it seems to be doing the thing. Go.
Well, great. Now I can actually play this thing, huh? Right, do I use like, oh yeah, here I can
Yeah.
run around? Are these guys on my team?
No, they're evil.
Oh, they just got me. How do I shoot? Like space?
I think it's Z as well. Either that or yeah, Z is shoot, and then X will be jump, and C will be grenade, I think.
I'm gonna grenade. There we go. Oh,
It can't hurt the pig. The pig is safe.
I
The
can't
pig is
hold the
good.
camera and do everything all at once.
The pig is on your team.
Go Chip, go.
I'm gonna get these guys. Z Z Z Z Z Z Z Z.
Those
I only
weird
got
guys,
one hand
they're
because
on your team.
I gotta hold the camera with the other hand.
Yeah.
All right, let's grenade these guys. Boom. All right.
Oh, you've got a weapon. You've got a weapon.
Oh, I gotta. All right. Well, super. So it's working.
Looks like it's working really well.
Yeah, it's working. Finally,
Congratulations.
it has worked. And everything was good for just one day.
What do we do with the hostage?
Yeah, you shoot him actually, or you don't worry, it doesn't hurt him. He just gives you like a weapon.
Oh, okay.
H stands for heavy machine gun, and he says it literally like that.
Oh no.
These were bombs, Chip.
Yep.
Yeah, for this you have to press up and shoot. It's certainly an
okay.
impossible challenge if you only have one hand to play the game with.
Right. Well, that's really cool, man. It looks great. It looks really good in person. It looks like just as sharp as can be.
Yeah, that's the thing, right? If you see me playing with the stuff over like the video share, it looks like ooh, even if it's a good capture to begin with.
Right.
Yeah.
And and even if it's a good capture to begin with and the video quality isn't getting destroyed, I don't think Zoom ever does full frame rate, right? It's always like 30 frames per second. But this game is also 30 frames per second, mostly.
It's still looking pretty good right now over this camera.
But
it looks fantastic, live. I mean, it's like pixel perfect.
Yeah, the colors look a bit weird for me, but maybe that's just the camera doing something. Could just be. Like it looks like the saturation maybe a bit much.
Yeah.
Like the TV store demo setting. Interestingly, I think I mentioned this before. I've actually got a new monitor because my old one broke. Can you believe what I have bought in the year 2023? A monitor with a VGA port.
Wow.
Yeah, they still make them. They still make them.
I like this futuristic font, which has kind of a gradient to it.
Oh yeah, it has a gradient to it.
That's awesome.
Game artists.
Yeah, this is extremely artsy, this game. Like you see all these little animations. Some of these are completely pointless, right? Like you have to specifically look for them to even happen. They just had a lot of fun animating all the different characters in this game. All the different characters, just like your guy and like the Green Army man. And like the weird POW guy. Well, there's all these background characters like especially in like the city stage, for example. At the beginning, you see some of them, and look, he crawls out of this little bunker thing. Like that's an animation that someone had to draw, right? That's not just something that happens on its own. And that's all been sort of like animated very beautifully, I think.
Yeah.
Ada, do we have any concerns about this being on the video?
No, I have bought it at least once, or even twice. I am good. And if any README file for the project, I actually link to where you can buy it.
Good. Okay.
I'm not sure if that does anything because like the people who worked at NASCAR in 1996 are probably not even remotely profiting off that.
Right. Right.
So
yeah, 28 years ago, think that was like yesterday to me. That was just a
but
little.
also it costs like $5 or something like that.
Ada,
It's
how
slightly more
old were you?
complicated to get the files out.
Ada, how old were you in 96?
Negative number.
No, you must have been born already.
No, I was born in. Actually, no, I'm not going to say my birth date on the recording.
So Chip, I have to ask, whenever you were doing all the work on the P2, did you ever envision it ever being able to completely emulate, like customized hardware like this?
No. Well, I mean, no. Well, I don't know. I was hoping it could do things, but I didn't really think about this kind of an application.
It's pretty stunning because that's custom audio, custom video.
Yeah.
Well, the audio is not really custom in that sense. It's a Yamaha chip that was off the shelf at the time.
Right, but you have no Yamaha chip in here, so it's a custom emulation now.
Yeah, that's surely it is.
Yeah.
But the video on the original Neo Geo is actually just a bunch of these, like these not really ASICs where there's like a bunch of logic blocks inside them and they just connect them together.
Right.
The original Neo Geo used like 4 of these or something to make the video happen.
Were they identical or different types of components?
Different. So there's one that's called LSPC that sort of coordinates everything, where the data moves from the memories. So it reads where each sprite goes on the line and figures that out. And it's also the only one of them that actually has registers that the CPU can talk to, like 4 of them. And then there's a line buffer chip, which in the original version was split in 2, which just holds the 12-bit color indices for each pixel in the scan line. And actually, then I forget what the other one was.
But
actually, maybe it was just those 3. I don't remember it exactly.
They were working their way towards understanding how to build ASICs, but cheaply, large-scale ASICs. Days.
I mean, that's kind of what that is, right? Is they only have to customize the one layer that connects everything together instead of building a full custom chip.
Yes.
I wonder what the technology was. Come on in.
Hey, Chip.
Hey there.
Meeting?
All right, we got these guys here.
Can I show some?
Oh, yeah, sure. Come on in. I wonder what the process technology was for this Neo. Did they call it what was the name of this system?
Neo Geo.
Neo Geo. I wonder what it was built in.
I mean, you can actually have die scans for the whole thing on the internet. You can actually look at it.
This is okay. See Ada talking here. Ada made this emulator. There's just some software that runs on the P2 and it emulates this whole game console from the 90s called Neo Geo.
Neo Geo. Yeah.
So this can't really. Do you have another P2 float around here?
Right here's one. There's one. Yeah. No.
So this is the chip that Chip designed, and then they make this.
These guys helped out.
They make this really cool product that this chip has a ton of power. Like it actually has 8 processors in that one chip that all run.
Yeah, that's why it could do all this simulation because he's got to simulate like video chips and audio chips and DMA and all memory access.
So he's running all this and you run on that chip right there.
Yep.
Oh, pretty wild stuff. Well, how small can you go down in the electron microscope? That's
I should keep this recording going. I can go ahead and stop it.
The electron microscope has a resolution of I think about 5 nanometers.
What is that?
It's like All right, how big is 5 nanometers? Can anyone explain?
What's a virus?
A virus
Small.
might smaller than 5 nanometers? Well, what's a hair? A hair is like 50 micrometers.
So like we were talking about thousands. This is probably 2 or 3 decimal places past.
Yeah,
Oh yeah.
I'm trying to think at what you would look at.
A human hair is 80,000 to 100,000 nanometers.
80,000.
To 100,000. So it's maybe 20,000 times smaller than a hair, than the width of a hair.
Right. So you're using it for this kind of stuff but like in the science field, what
Oh, I was actually
vaccine?
looking at the COVID vaccine with it.
Oh, the vaccine.
Yeah.
So you're with the vaccine, you're looking at